Advanced Algebra, Data and Statistical Reasoning 2.3. Let's look at some definitions. Okay, a population distribution is a distribution of a characteristic of all members of a population. Maybe you're wanting to know the heights of all the people in the United States of America, for example. That would be a population distribution. Often population distributions are very large. A sample data distribution is a distribution of a characteristic of the members of a subset of a population. So maybe you're going to select 100 random Americans and measure their heights. That would be a sample data distribution. We have a sampling distribution, which is a distribution of a statistic calculated from multiple random samples of the same size drawn from a population. Now we'll use an example to illustrate this. Let's go back to our heights, but we're not going to use all of the United States of America. Let's just go with 3 people. We'll say that this is your population, only these 3 people, to simplify things. Mark, Noah, and Omar, and you can see their heights. The population distribution would be simply those 3 heights. That's everybody in your population. The mean, by the way, is 70.3. We'll use the mean to make some illustrations. But the population distribution would be those 3. An example of a sample data distribution would be maybe if you chose the sample of being Mark and Noah only. Okay, this is very simplified because there's only 3 people, and here it's not real practical just to only take 2, but just to illustrate, a subset of the entire population, which is 3 people, would be 2 people, and you could take only Mark and Noah, and that 70 and 68 would be your sample data distribution. It's smaller than the population. Now this best illustrates a sampling distribution. Okay, so again, there's the same 3 heights. A sampling distribution would be if I take multiple samples. We'll say we'll take every possible, it doesn't have to be every possible sampling. Let's take, in this case, since it's such a small set, every possible subset of 2. So Mark and Noah, that would be 69 mean. We look at means here. Mark and Omar would have a mean of 71.5. You take the 70 and 73. And then Noah and Omar would have a 70.5 mean, which is easy calculations. What we did was just take 2 at a time and find their average. Those 3 numbers would be a sampling distribution. Again, sampling, not sample. Sample would just be the heights of one subset. But a sampling would be when you take multiple samples and you get some measure, and those measures would be your sampling distribution. Okay, so the standard says to distinguish between population distributions, that's everybody. Sample data distributions, that's just a subset, one subset of the total. And sampling distributions, which is multiple samples, and usually making some sort of calculation within those samples. Okay. Now the purpose of the idea of sample versus population is generally not feasible to measure every member of the population. Now if we had just 3 people, it'd be easy. Or it could be bigger than 3 and still be fairly easy. But when you're trying to measure all the people in a company, and just say you have thousands of employees, sometimes it's hard to gather every bit of information. If you're trying to find the heights of everybody in the United States of America, that's very, very hard to do. Therefore, samples are drawn from the population so that the measure of the sample represents the measures of the entire population. A lot of times you see this with voting. Okay, we can't ask everybody who you're going to vote for, but if we take a poll or a sampling and get their ideas, then that will somewhat reflect everybody's ideas. Now, of course, you can't just take 1,000 folks off the street. You have to very carefully pick your sample. So let's look at, this gets into the previous standard a little bit, but just some reminders. When you take the smaller group and you're trying to represent the larger group with it, you must be very careful. You really want to be random. That is, everybody should have an equal chance of being selected. You want to be free of bias or those prejudices that you might have for or against particular results. Okay, so when you're checking off, and these are some of the guidelines to check off a sample. Again, this goes into the previous standard, but it links nicely with this standard. You want to make sure that ethics and privacy are not violated, for one thing. You want to make sure that it's formed randomly and is free of bias. And you want to make sure to minimize any confounding variables. Okay, so again, the idea that a smaller group is going to be used to represent the larger group. Use sample statistics to make inferences about population parameters based on random sample from that population, and to communicate conclusions using appropriate statistical language. Okay, so that word inferences is you are using logic, you are using reasoning and evidence to make conclusions by population. A parameter is just a measure of a population, whereas a statistic is a measure of a sample. Again, you see that word random. Everyone should have an equal chance of being selected. And of course, you always want to use appropriate statistical language when you're drawing your conclusions.